For more than 50 years, a silent war has been fought above our heads. Not with missiles, not with armies, but with airplanes. Every day, thousands of aircraft cross the skies carrying millions of passengers across continents. To most travelers, these airplanes look almost identical. A tube with wings, rows of seats, a familiar logo painted on the tail. Yet hidden beneath those similarities is one of the most intense corporate rivalries in modern history, a rivalry that has shaped global aviation, influenced governments, triggered trade wars, destroyed careers, created fortunes, and changed how every one of us flies. Because behind almost every passenger jet in the skies stand two names, Airbus and Boeing. Both companies build aircraft designed to do exactly the same job. Both compete for the same airlines, both fight for the same contracts worth billions of dollars. And yet, they couldn't be more different. Point one believes computers should protect pilots from themselves. The other believes pilots should always remain in control. Point one was born from desperation. The other from dominance. Point one emerged as a government-backed alliance trying to survive. The other rose from decades of engineering leadership and military experience. But the most surprising part of the story isn't how different they became, it's why. Because the answer lies in a series of decisions made decades ago. Decisions that still influence every flight taking off today. And as this rivalry grew, it eventually led to one of the biggest engineering controversies in aviation history. Not a controversy that nearly brought down an entire company. To understand how that happened, we have to go back to a time when Boeing seemed unstoppable. The middle of the 20th century. Commercial aviation was largely an American game. The United States emerged from World War II with enormous industrial power, unmatched manufacturing capabilities, and a generation of engineers who had spent years solving some of the most difficult problems in aerospace. Among the companies benefiting from that experience was Boeing. Originally known for military aircraft and bombers, Boeing entered the jet age with a massive advantage. Its engineers understood large-scale aircraft production better than almost anyone on Earth. Then came the aircraft that changed everything. The Boeing 707, when it entered service in the late 1950s, it helped launch the jet age. Suddenly, international travel became faster, more comfortable, and dramatically more accessible. The world got smaller, and Boeing got bigger. But what happened next was even more significant. In 1969, Boeing unveiled an aircraft so large that many experts believed it bordered on insanity. The Boeing 747, the famous jumbo jet at the time, it was the largest passenger aircraft ever built. The aircraft was so enormous that engineers had to construct entirely new factories just to assemble it. Airlines loved it, passengers were fascinated by it, and competitors feared it. The 747 transformed long-haul aviation and became one of the most recognizable machines ever created. For many people, Boeing didn't just dominate aviation, it was aviation. From Seattle, the company appeared invincible. Yet thousands of miles away, a very different story was unfolding. Across Europe, aviation manufacturers faced a growing crisis. French, German, British, and Spanish aircraft companies possessed talented engineers and impressive technology. But individually, they lacked the scale needed to compete against American giants. Their aircraft programs were expensive, production volumes were small, and competing against Boeing was becoming increasingly difficult. Many feared Europe would eventually lose its entire commercial aviation industry. Then an extraordinary idea emerged. Instead of competing separately, several European nations would work together. The concept sounded almost impossible. Different countries, different governments, different languages, different engineering cultures, different economic interests, and yet they decided to build airplanes together. The result was Airbus. Today, Airbus feels inevitable. At the time, it looked reckless. Factories were spread across multiple countries. Aircraft sections were built in different locations and transported across Europe for final assembly. Engineers frequently struggled with communication barriers, political disagreements threatened progress, and financial risks were enormous. If Airbus failed, Europe could lose its place in commercial aviation altogether. That pressure created something unusual. Unlike Boeing, which was already successful and profitable, Airbus had something to prove. Its survival depended on being different. Merely copying Boeing wasn't enough. IT needed an advantage. And eventually, Airbus found one, but before that advantage appeared, the two companies developed very different views about a fundamental question. Who should be in charge of an airplane? The pilot or the computer at first glance? The answer seems obvious. Of course, the pilot should be in charge. After all, humans make decisions. Humans understand context. Humans handle emergencies. That philosophy became deeply embedded within Boeing's culture. For decades, Boeing aircraft were designed around the belief that pilots should always have the final authority. Computers could assist. Automation could help. Warning systems could advise, but the pilot remained the ultimate decision-maker. Even when Boeing later adopted advanced electronic systems, this philosophy largely remained intact. The machine served the human, not the other way around. Airbus looked at the problem differently. European engineers studied accident reports and noticed a recurring pattern. Again and again, human error appeared as a major factor. Pilots became disoriented. Pilots overreacted. Pilots made mistakes under pressure. The conclusion Airbus reached was controversial. What if the computer should sometimes override the pilot? What if technology could prevent people from making catastrophic mistakes? And this is where the story becomes truly fascinating. In the 1980s, Airbus introduced the A320 AT first. It looked like just another narrow-body airliner in reality. It represented a revolution. The aircraft featured fly-by-wire technology instead of traditional mechanical. Controls connecting the pilot directly to control surfaces. Pilot inputs became electronic signals processed by computers. That alone was impressive. But Airbus went even further. The company replaced a traditional control yoke with a side stick to a small control position beside the pilot. For many aviators, it felt shocking. Some compared it to a video game joystick. Others viewed it as a future. Yet the side stick wasn't the real innovation. The computers were. Because those computers introduced what Airbus called flight envelope protection, in simple terms. The aircraft will refuse certain dangerous commands that if a pilot attempted an excessive maneuver that could stall the aircraft or exceed safe limits, the computer could intervene. The aircraft effectively protected itself. Supporters saw genius. Critics saw danger. Debates erupted throughout the aviation industry. Could pilots become overly dependent on automation? Could computers misinterpret situations? What happens when technology encounters something it wasn't designed for? Nobody had definitive answers. But airlines noticed something else. The new Airbus aircraft offered practical advantages, and those advantages extended far beyond the cockpit. One of Airbus's smartest decisions involved standardization. The company designed aircraft families around common cockpit layouts and operating philosophies. Pilots could transition between different Airbus models much more easily than before. For airlines, this was enormously valuable. Training costs dropped. Scheduling flexibility improved. Operational complexity decreased. The savings added up quickly. Then, Airbus made another bold move to gain market share. The company aggressively pursued customers around the world. Flexible financing, creative leasing arrangements, competitive pricing. The strategy worked. Orders increased, market share expanded, and Boeing suddenly faced a challenge it hadn't experienced in decades. A legitimate rival, what began as a European survival project, was becoming a global force. The battle intensified. Boeing responded with upgraded aircraft. Airbus launched new programs. Governments became involved. Trade disputes escalated. Both sides accused each other of receiving unfair advantages. For years, the conflict extended far beyond engineering. IT became economic, political, strategic. National pride was now involved. And yet the most important battles were still happening inside aircraft design departments. As aviation entered the 21st century, both companies faced a new challenge. The future of air travel. Nobody knew exactly what passengers would want decades later. But each manufacturer developed a vision. Airbus believed major hub airports would dominate. Huge numbers of travelers would connect through giant international gateways. That vision inspired the Airbus A380, the largest passenger airliner ever built, a flying giant capable of carrying more than 800 passengers in certain configurations. IT was a masterpiece of engineering, a symbol of European ambition, the machine unlike anything the world had seen. But Boeing saw the future differently. Its engineers believed travelers increasingly preferred direct routes. Instead of connecting through giant hubs, passengers would fly directly between cities. That vision produced a 787 Dreamliner. Rather than maximizing size, Boeing focused on efficiency. Composite materials. improved fuel economy, long-range performance. The two aircraft represented completely different predictions about the future. Only one could be right. And over time, reality delivered its verdict. The Dreamliner fit changing airline. Strategies remarkably well. The A380 remained technologically impressive but commercially difficult. Many airlines struggle to fill such a massive aircraft consistently. Eventually, Airbus ended A380 production. IT was a rare defeat. But what happened next was far more damaging for Boeing. Because while Airbus was recovering from one setback, Boeing was heading toward a crisis of its own making. And almost nobody saw it coming. The roots of that crisis stretched back years. Many aviation observers argue that Boeing's culture gradually changed following its merger with McDonnell Douglas in 1997. Whether that perception is entirely fair remains debated. However, a growing number of engineers began expressing concerns. Some believe financial priorities were gaining influence over engineering priorities. Cost reduction became increasingly important. Shareholder expectations intensified. Competition with Airbus grew more aggressive. Pressure mounted. Then Airbus introduced the A320neo. The aircraft offered significantly improved fuel efficiency. Airlines loved it. Orders flooded in. Boeing needed a response. Fast. Designing an entirely new aircraft would require enormous investment and years of development. Instead, Boeing chose a quicker path. The company upgraded its existing 737 platform. The result became the 737 MAX that on paper, the decision made sense. Airlines had transitioned easily. Pilots required less retraining. Development costs remained lower, but the solution created engineering challenges. The new engines were larger than previous versions. Integrating them onto a design whose origins stretched back decades proved complicated. Engine placement changed. Aircraft handling characteristics changed. Engineers developed a software system intended to help address certain flight behavior concerns. That system became known as MCOS. Few outside Boeing paid attention to it initially. Then tragedy struck. The IN 2018. Lion Air Flight 610 crashed. Months later, Ethiopian Airlines Flight 302 crashed. Together, the accidents claimed 346 lives. Investigators discovered that MCOS played a critical role. Questions multiplied. Why was the system designed this way? How much did pilots know about it? Were regulators fully informed? Could the accidents have been prevented? The crisis exploded across global headlines. Governments grounded aircraft. Airlines canceled flights. Public confidence collapsed. Boeing suddenly faced one of the most severe reputational crises in modern corporate history. For years, the company that symbolized engineering excellence found itself defending decisions made under extraordinary pressure. The consequences were staggering. Billions of dollars in losses, leadership changes, intense regulatory scrutiny, and a painful reminder that aviation remains unforgiving. Every design decision matters. Every assumption matters. Every shortcut matters. Yet despite everything, neither Airbus nor Boeing disappeared. In fact, their rivalry continues today. Together, they still dominate global commercial aviation. Together, they produce aircraft carrying billions of passengers every year. And remarkably, they remain defined by many of the same philosophical differences that emerged decades ago. Boeing still places tremendous value on pilot authority. Airbus still embraces deeper automation. Both approaches have strengths. Both have weaknesses. Both have saved lives. Both have faced criticism. The truth is more complicated than declaring a winner, because aviation has never been a simple contest between humans and machines. It's about finding the right balance between them. Perhaps that's the ultimate lesson, hidden inside this rivalry. Airbus and Boeing didn't become different by accident. Their differences emerged from history, from culture, from politics, from engineering philosophy, from unique circumstances that shaped each company. Point one grew from dominance. The other grew from necessity. Point one trusted experience. The other trusted innovation, and together, they transformed aviation more profoundly than either could have done alone. Today, when passengers board an aircraft, most never think about these competing philosophies. They simply take their seat and prepare for departure. Yet behind every takeoff lies decades of engineering debates, political battles, technological breakthroughs, economic gambles, and hard-earned lessons written in both success and failure. The rivalry continues. New aircraft are being designed. New technologies are emerging. Artificial intelligence is beginning to influence aviation. Sustainable fuels are reshaping priorities. Future airliners may look radically different from today's aircraft, but one thing seems certain: as long as commercial aviation exists, Airbus and Boeing will continue pushing each other forward. And in many ways, that competition is exactly why modern air travel became as safe, efficient, and extraordinary as it is today. Because sometimes the greatest innovations aren't born from cooperation, they're born from rivalry.